Hey, fifth graders, this is Mrs. Trombley, and this is for any of you who may have missed our Zoom and small group time on Thursday, December 10th. So we'll start off with a number talk. Again, you want to do this in your head. You can pause in between. That is just fine. The very first problem we did today was 3 1/6 minus 5/6. So go ahead and get that answer in your head and press play when you're ready. Okay, so I had a lot of students that said, in my head, I borrowed from the 3 and I made it a 2. And I added 6/6 to the 1/6 to get 7/6, and then took 5/6 away. So 7 minus 5 is 2/6, and we get 2. So some people left their answers 2 2/6, and some other individuals said, well, wait a minute, I got 2 1/3 because I divided these both by 2 to get 2 1/3 in that simplest form. So 2 1/3 was the answer that we ended up at. The next problem that we did was 3 1/6 minus 3/6. And go ahead and get that in your head. Press play when you're ready. And I only saw one strategy come out today, and again, that was to borrow from the 3 and make it a 2, and to add 6/6 to the 1/6, which would be 7/6, and taking 3/6 away. 7 minus 3 is 4/6, and we had a 2 there. And some people said 2 4/6, and then we came to the conclusion that we could simplify that by dividing them both by 2. And the final answer people arrived at was 2 2/3. So that was the answer for our second one. And we did one more. We did 3 1/6 minus 1 2/6. And go ahead and figure that one out. Press play when you're ready. And again, we came up with one strategy today. Hopefully we'll have multiple strategies tomorrow. But people borrowed from this 3 and it was 2 and 7/6 again, and subtracted the 1 2/6 from it. 7 minus 2 is 5/6, and 2 minus 1 is 1. So we had a 1 5/6 for our final answer. So that was our number talk time. Then we went into breakout rooms and we solved some review problems because you're going to have a math test next week on Tuesday. Those review problems are in your Thursday folder, and it'll say problems that you need for small group today, or for the whole group and small group. So you can see those problems there, but we did this in our spiral. So you'll want to solve these in your spiral. You'll write down the problems and solve them. So go ahead and get your math spiral and a pencil and open up to the next clean page. And you can write up at the top, Unit 1 Review. This is the first part of it. And the first thing I asked them to do was to compare. So our first problem is 2/7 compared to 2/8. And again, you can go ahead and try it and then press play. We'll do that for all of them. I won't keep saying that over and over again, but know that between each one, pause, try it, play to see if you're right. So 2/7 and 2/8. I know that 2/7 is a greater because when my numerators match, the smaller denominator means I share with less people. So the 7s would be larger than the 8s. That same rule applies to 5/8 and 5/11. 5/8 would be greater because when the numerators match, this means I have 5 pieces for both. I have the same number of pieces, but if I have 5 out of 8, I'm only sharing with 8 people versus sharing with 11 people. So 5/8 would be greater. For number 3, the strategy that people used was they multiplied the 2/3 by the opposite fractions denominator and the 3/4 by the opposite fractions denominator so that we can compare the same denominators because the numerators and the denominators didn't match. So 4 times 2 is 8 and 3 times 3 is 9. Now when you have the same size pieces, more pieces would be greater. So 9/12 would be greater than that, than 2/3. Okay, the next section I had them write as a mixed number. So again, you're going to want to write these problems down, and all these problems are right in your assignments tab as well. The first one we wanted to do was 13/4. So as a mixed number, I want to see how many 4/4 there are in 13/4. And you can do that by asking yourself, 4 times what gets me closest to 13? Because I would be counting up by 4/4. So 4, 8, 12. 3 4s would be 12. So I can do 4/4, 4/4, and another 4/4. If I'm at 12, I need one more to get to the 13. And my 4 is the denominator. You could also look at this as counting up. Okay, so I have 4/4, that's 1 whole. I can get another 4/4 out of 13/4, that's 8/4, and then 12/4. And I can't do another 4/4, that would be too many. I only need 1/4 more, so 4, 8, 12, 13. Every time you see a 4/4, we have 1 plus 1 plus 1. So I would have 3 and 1/4. Okay, next one I have 20/3. So for 20/3, I'm going to do 20 divided by 3. You can look at it as that, or you can ask yourself, 3 times what would get me closest to 20? Because I want to continue to use this repeated addition. 3 times 6 is 18. And to get from 18 to 20, there are 2 left over out of 3. For 19/2, 2 times 9 gets me closest to 19. 2 times 9 is 18. And there's 1 left to get from 18 to 19 out of 2. And for 19/5, 5 times 3 is 15. And to get from 15 to 19, there's 4 left over out of 5. So I'd have 3 and 4/5. All right, moving along. Now we have a section, are they equivalent? So the first question I asked was, how can you tell if 2 fractions are equivalent? And we reviewed the fact that you can either multiply the numerator and denominator by the same amount, or you can divide the numerator and denominator by the same amount. And if those amounts match up over on this side, then yes, they are equivalent. Meaning this, 5 times 5 is 25. Now, if 6 times 5 is 30, then that means these are equivalent because I can multiply both the numerator and denominator by the same digit. And this does work out, so this would be a yes. All right, number 9, and again, you're writing this in your spiral. So in your spiral, you should have number 8, 5 6 and 25/30. You should show times 5, and say yes. For number 9, to get from 8 to 24, I can multiply 8 by 3. To get from 9 to 27, 9 times 3 is 27. So we just multiplied the top and bottom by the same digit to get this fraction. That means it's a yes. For number 10, I know that 12 minus 2 is 10, but I can't divide 12 by anything to get 10. And I can't divide 22 by anything to get 20. So you might be asking, well, isn't just taking 2 away the same thing? Well, look at 10/20. Isn't 10/20 equal to 1/2? Is 12 out of 22 equal to 1/2? So that means no, these are not equivalent. For number 11, going from 20 to 5, I can do 20 divided by 4 to get 5. And if 48 divided by 4 is 12, then we're in business. And if I count by 4s up to 48, it will take 12 of them. So this would be a yes. Maybe you looked at this as 5 times 4 is 20, and 12 times 4 is 48, and went backwards with it. That's totally fine. Multiplication and division are inverses. That works. For number 12, this is just a straight up no. The numerators match and the denominators don't. So 7 out of 12 is going to be different than 7/24. This means I have 7 out of 12 pieces. The whole's cut up into 12. This, the whole's cut up into 24. So that's going to be a much smaller amount right there. Okay, then we had to solve some addition and subtraction problems. So in your spiral for number 13, you should write 2/5 plus 1/3. And again, you should press pause. You should try to solve that. Press play to see if you got the same answer. For this one, I noticed that the denominators do not match, and I can't multiply 3 by anything to get 5. So I'm going to multiply each fraction by the opposite fraction's denominator. That would mean 3/3 here and 5/5 here. So the fractions I'm actually going to add are 2 times 3 is 6/15 plus 1 times 5 is 5/15. And 6 plus 5 is 11, and my denominator doesn't change, so 11/15 is what you should have. We only have a couple more. So in your spiral, you should write down number 14 is 3/4 minus 2/3. You can go ahead and work that out. Press play when you're ready. Okay, I noticed I can't multiply 3 by anything to get 4, so this is one of those where I have to multiply by the opposite fraction's denominator. I'm going to multiply this by 3/3 and this by 4/4. So the new fractions I have are 9/12 minus 8/12. All I have to do now is subtract my numerators. 9 minus 8 is 1. My denominator stays the same. And 1/12 is my final answer. We have 2 left. Number 15, 4 and 4/5 minus 3 and 1/4. The denominators don't match. The LCM is 20, so that means I'm going to multiply this by 4/4 and this by 5/5. So my actual problems are 4 and 4 times 4 is 16/20 minus, keep my 3, 1 times 5 is 5/20. Now when we subtract, 16 minus 5 is 11. My denominator doesn't change, and 4 minus 3 is 1. So 1 and 11/20. Last but not least, I have 1/2 plus 3 and 1/6. So you're going to go ahead and work that out. Press play when you're ready. For this one, I would not multiply 1/2 by 6 over 6 and 1/6 times 2 over 2 because I know the LCM is actually 6. I would just multiply 1/2 by 3 over 3, and then I would have 3/6 plus 3 and 1/6. For my answer, 3 plus 1 is 4, and 6 stays the same, and I just have a 3 here. So if on your test in Think Central you entered in 3 and 4/6, it would mark it correct. There is another way to write this though. You can divide the 4 and the 6 both by 2 to get 3 and 2/3, which would also be correct. This is the simplest form. And that is what you missed. Test is on Tuesday. See ya.